Example of steady-state processes. The purpose of a steady-state compressor and pump. The purpose of the steady-state compressor or pump compressor gas or pump liquid is the same. To increase the pressure of a fluid, by putting in shaft work. So we have shaft work in pump and compressors. Power on rate base. There are two fundamental different classes of compressor. Different classes compressors. The first one is the most common is a rotary type compressor. Either axial flow or radial flow, in which the internal processes are essentially the opposite of the two processes occurring in the turbines. Opposite of turbine inside processes. The working flow enters the compressor at low pressure. The working flow enters the compressor at low pressure. Moving into set of rotating blade. From which it exits at high velocity, a result of shaft work into the high due to shaft work. Then flow passes through a diffuser section in which it is decelerated in a manner that results in the pressure increase. So high velocity and pressure at first, and also goes to the diffuser, internal diffuser, to pressure increase. The fluid then exits the compressor at high pressure. The first law for compressor in either usually change in potential. The first law for the compressor or pumps, we have Q plus HI plus HE plus 1 second on indicates the change in potential energy are negligible. As is the inlet kinetic energy. And inlet kinetic energy. Often the exit energy is neglected as well. Exit kinetic energy in most cases are negligible. Heat rejection from the working fluid during the compression would be desirable, but it is usually small in rotary compressor, which is a high volume flow rate machine, and there is no sufficient time to transfer much heat from the working flow in rotary machine. Such as high velocity compressor, and pumps, also turbines. There is not enough time for heat transfer. So Q equals to 0, and it is adiabatic. Batic process. So we can eliminate the Q and also this is difference between 0 and in often cases. So W equals to HI minus HE, or in some cases W equals to HI minus HE minus the outlet velocity, outlet kinetic energy. And the working plan in this case reduces to change in enthalpy from the inlet to exit. In a piston cylinder type compressor, the cylinder usually contains fins to promote heat rejection during compression. In the piston cylinder, compressor, the cylinder usually contains fins to promote heat rejection. During compression, in this type of compressor, the heat transfer from the working fluid is significant and is not neglected in the first law. In this case, we have this relation for Q plus H I equals to HE plus velocity 0 W in the piston cylinder case. This is the end of in this section. The next section, there is also some problems related to the power plant and refrigerator. It consists of various devices. The transient process in the next section.